All right, there we go. So we are given some information here, a couple of important pieces of information. First off, that the derivative of f is always positive, and that the integral from 4 to 7 of f is 0. And so we want to know which of all these different tables that they give us could potentially be a table of values for the function f. So first off, if the derivative is positive, this tells us that f must be increasing from 4 to 7. So f is going from -4 to -3 to 0, so that's a possibility. -4 to -2 to 5, that's a possibility. -4 to 6 to 3, not a possibility because it starts decreasing. Choice D, 0, 0, and 0, not a possibility. And then 0, 4, and 6, those are all increasing, so that's a possibility. So we can immediately eliminate choices C and D based on the first piece of information we're given. And then second, we know that the integral from 4 to 7 has to equal 0. Well, if I have a function from 4 to 7 and the area underneath that curve is 0, that would tell me that I had to have some portion of this curve that was below the x-axis and some portion that was above the x-axis, so that the part above, the positive part of the integral, would cancel out with the negative part of the integral. So it has to go from a negative value at 4 to a positive value at 7. And I have to have some negative values of f of x and some positive values of f of x. And choice A, I've only got negative values and then go up to 0. So this one would look, it's like choice A would look something like this. Well, that's going to have a negative integral from 4 to 7. And choice E would look something like this. It's going to have a positive integral. And so the only one that starts negative and goes positive is choice B, so that the section above and the section below can cancel out. So does that make sense there for number 86? Any questions there? All right. Let's see. Next up, we're looking at the 2008 test. So let me go find that one. And number 45. Maybe. Man, my computer is having some issues today. There was yesterday also, but it is today too. All right. So here is number 45 from the 2008 test. So we got a city that is located beside a river as a rectangular boundary, blah, blah, blah. The population density of the city at any point along a strip that is X miles from the river's edge. So we're going from here to here. Given anything between here and here, the density is f of x. And we know that each strip of land that we're talking about is, 7 miles long. It has a very small thickness of dx. And so if we were to try to figure out the actual population of the city, that should be the density in people per square mile times the number of square miles. And so we know that the number of people in a single strip of it, so in one of these strips, the number of people is 7 times the density times the width of that strip. And so all we need to do is take that function and integrate it from 0 miles from the river's edge to 4 miles from the river's edge. And so that looks like that should be choice B. They just pulled the constant out into the front. And so, yeah, does that make sense? I mean, it's got to be 0 to 4. It can't be 0 to 7 because we're talking about in the x direction. And yeah, I mean, each of these strips is 7 miles wide, so it's not going to be 28. It's not going to be a constant of 1. It's just going to be the constant of 7. Does that make sense? Who asked for that? No, I don't remember who asked for that. Lorelei, does that make sense? And
yeah, thank you.
Let's see, and then 1D and 3B, those are the free response ones also that you're talking about, I assume?
Yeah.
Okay, so let's see here. 1, maybe. Man, my laptop is really giving me some trouble today. All right, so 1D. So the rest of this one, find the area, should be pretty straightforward. Upper function minus lower function. And then they split it at y equals -2. So then still upper function minus lower function. Base of the solid, cross sections for squares. So that should just be, you know, upper minus lower squared, integrated from 0 to 2. But then part D says the region R models the surface of a small pond at all points in R, so in our region, that are a distance x from the y-axis. The depth of the water is given by h of x equals 3 minus x. So we are looking for the depth, sorry, not the depth, we're looking for the volume, which should be whatever the cross-sectional area, which is just going to be our depth here of 3 minus x times the length of the cross-section, which is r. So it ought to be 3 minus x times, we've got sine pi x minus x cubed minus 4x. So it's just the length from here to here times the depth of it, which is basically giving us the area of the cross-section. And then integrated from 0 to 2. And then your calculator can evaluate what that is for you. Does that make sense?
Yeah, thank you.
You're welcome. All right, and then what was it? 3B, okay. All right, so for 3, we got oil leaking, et cetera, et cetera. It's forming an oil slick. It's got a volume that's increasing at this rate that's given to us. And it looks like a right circular cylinder. Its radius and its height are changing with time, et cetera. Okay, so part A said that at the instant when the radius is 100 centimeters and all that, what is the rate of change of the height? So hopefully we went through and did that all right. But 3B says a recovery device arrives on the scene and begins removing oil. The rate at which we remove the oil is 400 root T cubic centimeters per minute. And so then they want us to find the time where it reaches its maximum volume. So in order to do that, we've got to write a function that represents the volume. And so our volume should, well, let's see, We don't need one for our actual volume. We just need one for the rate of change of our volume, because if we can figure out when the rate of change of the volume equals 0, that should tell us when we might be at a max. And so our rate of change of our volume with respect to time should be the amount that it's leaking minus the amount that it's being removed, which would be 2000 minus 400 root t. And so that is the derivative of the volume function. And so we need to set that equal to 0. Looks like that'll equal 0 when if 400 root t equals 2000, which, let's see, what is that going to do? That's going to be root t equals 5, or t equals 25. And so then we would need to figure out if this is a max or a min. We need to show if it's a max or a min. And so we just do that with the sign chart. Plug in something like 24. If I plug in 24 to this, I'm going to get something that is greater than 0. And if I plug in something like 26, I'm going to get something that is less than 0. And so we'll see that it's a maximum when t is 25 minutes. I think it was minutes, right? Yeah, cubic centimeters per minute. Does that make sense?
Yeah, I think I found the derivative of dv dt instead of knowing that it was already the rate.
Yeah. So it talks about volume. We're looking for maximum volume, so we need to look at a rate of change of volume, and both of these are rates, right, per minute and per minute. So
right.
We can combine those together. Yep.
Yeah, thank you.
You're welcome. All right, let's see. Next one that somebody asked here for was 2C from the 2012 test. So let me find that real quick. Maybe. All right, so here is, let's see here. There's number 2, and then part C is asking us that in there also. So part C is saying we got the horizontal line y equals k. That's dividing R into 2 regions of equal area. And we want to write, but we don't need to solve an equation involving one or more integrals to give the solution of k. All right, so we got a horizontal line. This is y equals k. Obviously, I drew it in the wrong spot, but that's fine. We just need these 2 regions to have equal area. So if we're going to do this the easiest possible way, we're going to want to do this in terms of y. We want to go from the low value to the highest value. That should make life easier, because if you look at it in terms of y, the rightmost function is always the linear one, and the leftmost function is always the logarithmic function. If I tried to do it in terms of x, which you could do, it's just a huge pain. My upper function is the logarithmic function. Then my upper function is a horizontal line. Then it's this other line. So you got to break it up into multiple, 3 different integrals. So that's a huge pain. So the best thing to do would be to say that we need to set y equals 5 minus x as x, x equals 5 minus y, and y equals ln x as x equals e to the y. And so then we will integrate from 0 to k, because this is k where this horizontal line is, the rightmost function minus the left function, dy. And then you have 2 options. One, you can just say that that's equal to, and I believe in part A, they had you find the full area. So you can just say it's equal to 1/2 of the answer from part A, and you're done. Alternatively, you could say that it is equal to an integral from K to whatever this intersection point is of the same thing. That'd be fine also. Or you could just say it's equal to 1/2 of the integral from 0 to this intersection point of 5 minus y minus e to the y also. But this answer right here is probably the quickest, easiest one to get.
Could I say that like the integral from 0 to k minus the integral from k to like the intersection point is 0 since they're the same?
Sure, that'd be fine too.
Okay, cool. Thank you.
Yep. Anybody else have any questions? That's the last one that somebody asked for. I assume you guys have done more than just a few of these problems. You guys are either doing an amazingly great job and know all the answers and are having your trouble, or you're not doing it. Nobody has any more questions. Okay. So I guess here's what I'm going to say.